Okay, I'm going to go over our notes that you picked up on Friday. You're going to have steps here that you need to memorize and recognize for each special segment. Although we have, at the very beginning, it says we have 5 special segments, we're only going to write equations for 4 of them. So if you need to pause the video and copy down these 4 steps, understand with my font, it got kind of lengthy and it might come off the paper, but you want to make room to get those steps in and we're going to memorize them. Step 1 is we got to find the midpoint because a perpendicular bisector goes through the midpoint of the side and is perpendicular to the other side. So we're going to start off with plotting these points that are given to us. So get this on the graph that's provided for you. We have A is a negative 4, 1. Put a point there, label it A. B is 2, 7. Put a point there, label that one B. And my C is 8, negative 3. Alright, and we are going to connect the points, create our triangle. So, draw my segment there, segment there, draw my segment there. I think they should be connected. Alright, so find the midpoint. After we have our triangle form, we need to find the midpoint of the side. So they want us to find the midpoint of the side AB. Now, to do that, I can just use my midpoint formula. My midpoint formula says basically I'm going to do x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Well, I see right here, there's my x's. A negative 2 and 2 is a negative 2 divided by 2 gives me my negative 1. And there are my y's. Add them together, 1 and 7. 8 divided by 2 is 4. So my midpoint for my side AB is negative 1, 4. And notice that you could physically see that on the graph. So you could use it, like use your slope, take half of it, and then plot the point. After we find that midpoint, we're then going to find the slope of AB. Well, I can get the slope of AB. Let's get a color here. Let's try that. We can get the slope of AB doing our rise over run. So I would go up. This is 1, 2, 3, 4, 5, 6 units. And then I would have to go to, oh, I went too far. It is 6 units, but I stopped. All right, so it's 6 over 6. So I'm hoping we can see that I can do my 6 over 6. It's just a slope of 1. Okay, so we know AB has a slope of 1. So the third step says we're going to find the perpendicular slope of that side. So if I know the slope is 1, then the perpendicular slope has to be a negative 1. Let's get this a different color so one can see it. So then we are going to write the equation in point slope form. If we look here on our notes, it says that we want to use the point slope form for the equation that changed to slope intercept. Now, only changes to slope intercept form if they ask it for the equation in that form, or if we're going to have to find the perpendicular's point, the bisector's point of concurrency, because it's easier if you put it into slope intercept form to substitute, or standard form to use elimination. So we are now going to take the midpoint, and our midpoint that we had here, I'll put my M back up here, my midpoint was negative 1, 4, and then we're going to use the perpendicular slope, and the perpendicular slope of AB was a negative 1, and then we're going to just plug the equation into point slope form. So we're just going to do y minus 4 equals negative 1 parentheses x plus 1. And then we're going to change it into slope intercept form. So the easiest way for us to do that is we're going to distribute that negative 1. So we have y minus 4 equals a negative x minus 1. And then we're going to add our 4 to both sides. And we'll have it in slope intercept form, which is y equals the negative x plus 3. I'm going to box that. And there's our equation for our perpendicular bisector. But we are going to be asked to find the location of the circumcenter. And the circumcenter is your point of concurrency for all perpendicular bisectors. So what I need to do is I need to actually physically see this. And in order to do that, I'm going to start with this midpoint, which is at negative 1, 4, and use its perpendicular slope, which was negative 1. So that means I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right. I know some of these points are off. Apologize. But we're going to draw a line through those points to show the perpendicular bisector. So, and I want you to understand, and it states this, that your perpendicular bisector does not have to go through the opposite vertex. I think I keep that on line right there. So we see here, it doesn't hit a vertex C. It's still perpendicular because it's an opposite reciprocal slope of the slide AB, and it's a bisector because it goes through the midpoint, so I'm going to add my tick marks. But we're going to repeat these steps, for all three sides, because we have to see all three perpendicular bisectors to figure out the orthocenter, because that's the point of intersection. So we're going to do the exact same thing for AC. So let's look at side AC. We need to find that side's midpoint. Or I can just do my xy plus x2 divided by 2. Or I can count, but basically I want to find where that midpoint is. And I'm hoping that you can see that it looks like it's at 2, negative 1. Well, I can check it. A is a negative 4, plus C is 8, divided by 2. And then I can do 1 plus the negative 3, sorry, divided by 2. So yeah, it is at that point. So our midpoint for AC is 2, negative 1. And then we also need to find the slope, because that's step 2, find the slope of AC. So I can physically count the rise over run for AC, and I can see that it's decreasing if I read it from left to right. And basically I would have to go down 4, and then to the right, 1, 2, 3, 4, 8, 9, 10, 11, 12. So the slope of AC, negative 4 over 12, which can be reduced to, you got it, negative 1/3. All right, step 3 now tells us to do the perpendicular slope. So we're going to do the perpendicular slope of that negative 1/3, and we get 3. So I'm going to now draw my perpendicular bisector to know the point of intersection to get to my circumcenter, because that's the point of concurrency for all three perpendicular bisectors. So I'm going to start at this point. That is my perpendicular bisector, bisector, and I'm going to go up 3 to the right 1, and then up 3 to the right 1. I'm using the perpendicular slope again. And let's get, I guess we can stick to the purple on my line, which is off. I need to fix it. Just bear with me. Let's go to the midpoint. And there we go. There's that line. And remember, we're doing this for all three sides. So we are going to need to repeat these steps, and practice makes perfect. So get practicing repeating them. And we are going to do it now for side BC. Find its midpoint. If I look, I think I see it. I see it. The midpoint of BC is at 5, 2. So I'm going to put a point to represent that midpoint. And I'm going to put it at 5, 2. And then I'm going to find the slope of BC. Again, I can count the rise over run to get that. And again, we see the slope is decreasing, or the line's decreasing. And this is a negative 10 over 6, which is a negative 3/5, or 5/3, excuse me. Sorry, put that backwards. And then we're going to do the perpendicular slope, which is the 3/5. Flip it and change it. Flip the ratio, change the sign. Now, I'm going to start at my midpoint of side BC, and I'm going to use my perpendicular slope to plot additional points to get to my line. So the slope of 3/5 We'll go up 3, 1, 2, 3, to the right 5, 1, 2, 3, 4, 5. Or I could go down 3 and to the left 5. And notice again, the line does not have to go through the opposite vertex. It does that with special cases. So I'm going to connect my line here, creating the perpendicular bisector. I'm going to put my little box, and 2 tick marks to show that's a perpendicular bisector, and I forgot to do my box on my purple line. And what we're trying to do is we're trying to find the point of intersection for those 3 perpendicular bisectors. If I look, I can't really get an exact point off of this. It's not an exact point, but we can still find it. So what we can do is we need to find the equation of another side. We're going to let's use the side that we just did, the BC. So let's go ahead. We have the point, right? And we have the slope. So let's put it in point slope form. We got y minus 2 is equal to that 3/5, parentheses x minus 5. Let's go ahead and put it in slope-intercept form. So we're going to distribute. That would give us y minus 2. Let me scroll this up a little bit. Y minus 2 equals to 3/5 x minus 3. And then we're going to add the 2 to both sides. And basically get y equals 3/5 x minus 1. So we're going to use this equation, and we're going to use our original equation for the perpendicular bisector for AC. And what I want to do is I can find the point of intersection by finding the values for x and y. Now there's 2 ways I can do this. I can do substitution, or I can put it into standard form. Let's do substitution, because we haven't talked about that in a while. So with substitution, basically I'm taking what the value of y is, and I'm going to plug it into the equation. So I'll show you what that looks like. We know y equals a negative x plus 3. So I'm going to plug it in for the y that's in this equation down here. So I'm going to have a negative x plus 3 equals 3/5 x minus 1. And now we're going to solve for x. So we are going to, I would prefer that we get rid of the fractions first. Remember how we had to do that? So we can get nice whole numbers when we're dividing. So if I get rid of the fraction here, I'm going to need to multiply everything by 5. So we're going to multiply everything by 5, and that would give me a negative 5x plus our 15 equals, we now have 3x minus 5. All right, now I can see nice and neat 2-step, possibly maybe 3-step equation to solve this. So we're just going to get rid of the smallest x, which is the negative, at the 5x. The x's will cancel out, leaving me 15 equals 8x minus 5, and then we're going to add our 5. And this makes sense because it's not an exact point. It's not a whole number. We look at what we have here, the intersection of those 3 perpendicular bisectors are not an exact point. So it's going to give us a fraction. We're going to divide it by 8 on both sides. We're going to reduce that. And hopefully we get, and you see, 5/2 equals x. So basically, our x coordinate is the 5/2 for the point of intersection. Because if I can find the intersection of 2 lines, and the 2 lines that we're using are my blue line and my purple line, well, that point of intersection is the same point of intersection for any 2 perpendicular bisectors that I pick. So once I have the x, I can go back and plug it back into what I had up here to solve for y. I'm going to take this x, put it right here. We had the y right in here. We had y equals a negative x plus 3. So I'm just going to substitute a negative 5/2 plus 3. Well, what would that simplify to be? That would be 1/2. So there is my location for my circumcenter. It's the intersection of those two lines using a system, substitution, or standard form, using elimination to solve for them. Thank you for getting that one done. Watch the next video for medians.